the fin-fan coolers or the cooling towers, which are the most common sight in the refineries, fertilizer complexes, power plants, and other industries, wherever there is a heat transfer taking place and a cooling requirement is there. I would just like to go ahead. We are talking of the concept of energy conservation in a larger sense, but in the specific sense, we are talking of improving the throughput from the fin-fan coolers or the cooling towers. Basically, we have been in the field of development of these particular energy efficient fans right from 1989-90. We did fundamental work on this, as you will see when I go through the whole thing. But certainly whenever you need a breakthrough in developments, you need to do basic research and development to see, as the chairman has already said to you in his opening remarks, be inquisitive and be open to look at things, how to improve on what you can do in the equipment. This has been our basic design and company philosophy right from the inception of this company. And we have always been looking at how to do things better. And certainly, in anything that you want to improve the efficiency, there is a theoretical and more than anything practical limit to push the efficiencies to very high levels. So our equipment, which we are going to talk about, is the axial flow fan, which is most commonly used in all these air-cooled heat exchangers, or the fin-fan coolers as we call it, and the cooling towers. How they're going to be energy conserving or improving the efficiency is given there. We designed the fans to deliver the same airflow at the lower motor input power. This is what we call this particular system as energy conserving mode. The other one is, most of the time when you install a system, by the time you come up onto the full load, the original equipment manufacturer is almost off your hook, basically because the warranty period is over. When you're already actually running up to the full load, there seems to be some time lag by the time you come up to the full load, and then when you come up to the full load, you find that the equipment is not operating to the design levels. This is where you obviously think there is a bottleneck, and so you want to see how to reduce the bottleneck. That is where we call de-bottlenecking as the common norm that has been used in many industries. So this is where an energy efficient system that we can give. One is, if somebody is happy with his operation of the axial flow fan at the desired airflow that they have been achieving, then we can conserve energy by giving you an aerodynamically superior design so that you save on the operating cost from the point of view of simple motor power consumption. The other aspect, which is actually a larger benefit to the end user, is if you can increase the productivity by seeing that your de-bottlenecking is taken care of. Most of the time, the plants are operated beyond 100% with the pressures of time and productivity nowadays. Everybody wants to push it to 120%, 125%, or minimum of 110% than the design without having to do anything much. Obviously, you don't get that unless your equipment has been highly overrated. With the pressures of competition, most of the manufacturers are trying to cut corners when they offer you a design, and so most of the designs are not able to give you the increased throughput when you really want to do it. That is when you can use this kind of fans to de-bottleneck your systems. What we are seeing is delivering higher flow at the same motor input power. There are certain cases where you need higher airflow. In those situations, you may not be able to do with the same motor. So there are very few cases where we had to change even the motor, but then that's a smaller modification in the entire system than having to add few more banks of the fin fan coolers. So this is what we have been able to achieve with this particular product, which will share a little bit of information. Okay. It says it all. Anything like a cooling tower or a fin fan cooler looks so simple. You expect it to slog it all along. You just push something which is very hot inside. You want to have it cooler. So it's so simple that it looks so people generally don't give maximum attention to it while it's operating. So it's only while it's malperforming that people start questioning where is this problem that is occurring. So this is what, as you know, these are high energy utilization machines as well as heat and mass transfer design. Whenever you're looking at the scope for efficiency improvements, there are a few points which one has to understand. The main thing is the knowledge of the actual performance in relation to design. This is not usually done. They only know that it's malperforming, but how much of it is off the design, one needs to make some basic measurements to know how much you're off the design. And then, what are the critical components of your system? Is it just the fan, or is it the fin tubes, or the cleaning of the tubes, or the better importance of the higher airflow of the fan system, or is it that the belt system that you're using has been slipping quite a bit, so you don't have the full speed of the fan, and so when the speed of the fan reduces, the airflow automatically reduces. So that's critical component of the system one has to have a little bit of knowledge of. And then awareness of superior efficiency levels in latest and proven technology. I think that's what we're all here for, to learn from each other. What are the superior technologies that are available, and we become aware and then see how whether anything can be useful to us in the real time. The options or potential of design modifications. As I briefly already told you, what are the design modifications and options? The selection and adoption of re-engineering methodologies to achieve sustainable solutions. These are certainly the aspects that everybody would be keen to look into whenever they're looking at the process of finding out for methods of energy efficient improvements. Well, how is it going to be better than what you're using is the first question that comes to everybody's mind. We have looked at various options, and we have come, not the only people who have come to the conclusion that if you need an energy efficient design, you need a better aerofoil to be used along the full length of the blade. And of course, the precise aerofoil design that you need would be possible mainly with the material called fiber reinforced plastic, FRP. That's what we are calling. And these blades are made hollow basically to be able to get the maximum twist that is possible and obviously to reduce the weight. It's like a concept of pipe design in a transmission shaft. You don't need a solid shaft to use it for transmitting the power over a long distance. What you people do is you use a hollow pipe to transmit the power. So it's at the outer edge that you need the thickness to take care of the stresses. And so your design concept is basically that which has been translated into this. Before these fans have been developed so many years back, there have been solid aluminum blades, and then there are thin sheet aluminum blades which are riveted. But the point there comes is whether you're able to have varying twist and varying widths of the blade along the full length of the blade, about which I'll be talking to you. So to achieve these, we have found that when you use fiberglass reinforced plastic material, you can achieve this almost ideal situation. This is a typical installation which must be common to many people who are from the refineries, where you have an air-fin cooler. This is a forced draft air-fin cooler. So, obviously, there are disadvantages and advantages of using a forced draft as well as induced draft, about which we will get later. So this particular efficient fan that has been given in Petronas refinery some time back in Malaysia, and this is a closer view of the blade which is there, the fan. These are some of the simple photographs that we've done in some work in trying to replace some of the large 10.4 meter fans. The interesting thing is those blades which are there, they are 4 in number, and they were also fiberglass blades. And still, we could chip in there to conserve the energy by giving them a superior aerodynamic design of these blades. So the key is, it's not just the aluminum blades or the metal blades or the steel blades or the fiberglass blades. Just being fiberglass doesn't mean you're getting a superior design unless one goes into a little bit more into detail. These are some of the systems where for that particular cooling tower, we also do airflow measurements. Obviously, to cut the whole thing short on performance measurements, what we need to do is, we are talking of increasing airflow, we are talking of drop in water power consumption. How are they quantifiable is the first question that crosses anybody on the plant. The way to do